How did Vikings navigate? It is almost unimaginable for modern humans to conceive of making long voyages across the open sea without some form of navigation instrument. Although some artifacts from the Viking era might have served as navigational tools, there is no certainty that the Vikings relied on anything other than their senses to navigate. They had a deep understanding of nature, but their observations did not result in scientific data that could be used to create precise instruments. They were familiar with the cardinal directions of east, west, south, and north. However, their navigation was more based on observing the position of the sun on the horizon and its height during the day, rather than Earth's magnetism, which is the basis for the modern compass. The sun, moon, and stars provided the Vikings with a reliable sense of direction. However, in foggy or cloudy weather, these celestial bodies were not visible, and over long distances, even a slight deviation from the planned route could result in completely missing the intended destination. To mitigate this, the Vikings also monitored landmarks when sailing across the coast. Distinctively shaped rocks or hilltops, for example, could offer valuable clues about their location. You could find descriptions like this in the Hauksbok manuscript of the Book of Settlements. Quote, "Knowledgeable men say that it is 7 days sailing west from Stad in Norway to Hon in eastern Iceland. From Snæfellsnes in Iceland, it takes 4 days at sea to reach Hvarf, Cape Farewell in Greenland. From Hernar in Norway, it is necessary to sail due west to Hvarf in Greenland, passing to the north of Shetland, so that it is just visible when visibility at sea is good. Then the road lies far enough south on the Faroes that the sea is halfway up the mountains, and far enough south of Iceland that there are both birds and whales. From Reykjanes in the south of Iceland, there are 5 days at sea to Cape Slinen Island to the south. There are 3 days sailing from Langanes in the north of Iceland to Svalbard in the north at the head of the sea, the Arctic Ocean then regarded as a gulf. From Kolbeinsøy to the uninhabited parts of Greenland, it is 1 day's sail northwards." End quote. While sailing, the Vikings also used wildlife as navigational aid. Birds were especially useful, as some species only flew a certain distance from land. For instance, if they had long passed the Faroe Islands and saw a specific terrestrial bird, it could indicate that they were near Iceland. Whales, which typically stayed close to fish-filled currents, also provided navigational clues. The Vikings' knowledge of whale habitats helped them gauge their position relative to locations like Iceland. Experienced sailors relied heavily on their senses. In dense fog, they could estimate their proximity to land by listening for bird calls or the sound of waves crashing on the shore. Additionally, the sense of touch on their faces helped them detect changes in wind speed and direction, providing insights into wind swells from different directions. Nearby coast could reflect these swells, allowing a seasoned Viking sailor to gather valuable information from the sea breeze alone. One of the few navigation instruments available to the Vikings was a plumb bob, which they used to measure water depth. This tool also collected small samples of the seabed, which the sailors could taste and touch. An experienced mariner could identify characteristics of the seabed by taste, possibly even detecting fresh water flowing from land into the sea. Additionally, a seasoned sailor could smell the proximity to land. In humid conditions, the human nose can detect the scent of trees, plants, and fires from some distance away. But sometimes none of this could work, and you would find yourself, of course, lost at sea in very dangerous circumstances, or extraordinary ones as well. According to one historical source, the Grænlendinga Saga, the saga of the Greenlanders, America was discovered by accident in the autumn of 996 AD. The saga recounts the journey of Bjarni Herjolfsson, believed to be the first European to sight North America while en route to Greenland to visit his father. Having learned the route from Norway to Greenland, Bjarni encountered several days of strong northerly winds and fog, which blew his ship off course. Despite his efforts to steer back on track, Bjarni ended up sailing due west and eventually sighted a piece of land that appeared more fertile than the Greenland he had heard about. His crew wanted to go ashore, but Bjarni insisted on reaching Greenland before the end of the sailing season. He then headed north, observing that the land became less fertile and rockier. Finally, he saw terrain resembling the descriptions of Greenland and landed near his father's residence. Bjarni Herjolfsson was not celebrated for discovering new land. On the contrary, he was mocked for his reluctance to explore further. Nonetheless, his travel tales inspired Leif Erikson to launch his own expedition. Leif bought Bjarni's ship, assembled a crew of 35, and set sail on his own voyage. But what about sunstones, like the one Ragnar uses in the series Vikings? Although one must say they did know the way to the British Isles before the 8th century. There is speculation that Vikings used sunstones for navigation, but no sunstones have ever been found in Viking excavations. The oldest known sunstone that might have been used for navigation was discovered among the wreckage of the warship Alderney, which sank between England and France in 1592. Some archaeologists have hypothesized that this crystal was used for navigation because it was found about a meter away from another navigational tool. The Icelandic manuscript Ráðólfsdóttir, written between the 12th or 13th century, has often been used to prove that the Vikings did use a sunstone as a navigational tool. This manuscript contains a short story from around 1030 when the Norwegian king Olaf Haraldsson II visited a rich farmer by the name Ráðólfur. In this story, late in the night, his son Sigurd was asked about his attributes. He told the king that he has mastered a skill where he can tell the time of day and night even if the sky is hidden by clouds. Quote, "The weather was thick and snowy as Sigurd had predicted. Then the king summoned Sigurd and Dag, Ráðólfur's sons, to him. The king made people look out and they could nowhere see a clear sky. Then he asked Sigurd to tell where the sun was at the time. He gave a clear assertion. Then the king made them fetch the solar stone and held it up and saw where the light radiated from the stone and thus directly verified Sigurd's prediction." End of quote. When using a sunstone for navigation, you're not looking for colors but for shadows. By drawing a dot on the top of the crystal and looking through it from below, you will see two dots. If you hold the crystal up to the sky and rotate it until the two dots have exactly the same intensity or darkness, the upward-facing surface of the crystal will indicate the direction of the sun. There is no doubt that the sunstone could be used to locate the sun. This method with a dot has been tested and it was possible to find the location of the sun within 1 degree, even on cloudy days, or under dark twilight conditions when the sun was just 4 degrees above the horizon. A study was conducted by Gabor Horvat and Denis Sas at the Eötvös Loránd University in Budapest. Their research concluded that not only could a sunstone have been a possibility, but in fact it might have been the method they used to reach Greenland. The research was conducted with the use of computer simulations based on the theory that the Vikings used Bergen in Norway as a starting point to sail to the settlement in the south of Greenland. The study conducted thousands of computer simulations along the 60 degrees north latitude. The Viking voyages were simulated for 2 specific dates: spring equinox, the 21st of March, and summer solstice, the 21st of June. The solar elevation angles were calculated for the latitude on an hourly basis. The speed of the Viking ships was set to 11 kilometers an hour. The Vikings used different types of ships with different maximal velocities, therefore they chose to select an average speed of an average-sized ship with a mass of 21 meters in height. This means that the trip would have taken approximately 3 weeks to complete. If the sunstone was used every 1 to 3 hours at spring equinox at summer solstice, then there would be a success rate between 92% to 100% to arrive at their destination in Greenland. However, if the sunstone was used every 4 hours, then there would be only a 32% to 58% chance that the voyages would be successful. If the sunstone was used every 5 hours, then the chances of success would drop to below 4% at summer solstice, but surprisingly, at spring equinox, the chances of success were approximately 100%. If the sunstone was used every 6 hours, then the success rate drops to 3 to 6% at spring equinox and 0.9 to 1.9% at summer solstice. Based on these results, the researchers concluded that the use of sunstones for navigation is surprisingly successful at spring equinox and summer solstice, even in cloudy weather if the navigator uses it at least once every 3 hours. So after this research, the hypothesis doesn't sound that far-fetched any longer. However, it is still a hunch. There is really no proof this actually happened, but that it could have happened. Maybe Bjarni did not use a sunstone at all and just failed in his measurements. There is yet another candidate for Viking navigational tools, the sundial from Unartok. This method involves using a vertical pointer on a horizontal surface, where the shadow of the pointer, known as the gnomon, is traced throughout the day. The shadow's path varies at different latitudes and times of the year, necessitating a series of curves for navigation. The partial device, resembling a portion of a wheel or disc, had notches carved around its perimeter and intentional scratch marks across its face, indicating solar alignment. A round peg protruding from the center of the dial allowed the Vikings to measure the sun's position in the sky. The key was measuring the sun at the same time each day and noting changes in the shadow it cast. For example, far north of the equator, a noon measurement might cast the shadow to the north. As one sailed closer to the equator, the noon shadow would shorten, eventually passing directly beneath the sun, then growing longer on the south side of the compass as one traveled further south. However, the sun's height, known as declination, changes throughout the year, requiring a declination table for extended journeys. Around midsummer, the variations in declinations are minimal though, making it easier for practical navigation. The aforementioned study addresses this object as well. One issue with the sun compass interpretation is that the nomic lines do not extend all the way to the edge of the dial but terminate prematurely. This truncation would have made it impossible to mark the path of the sun's shadow past a certain time in the late afternoon. Another issue is that the nomic lines and some other lines on the dial are slightly misaligned by a few degrees, potentially sending sailors many miles off course. The researchers suggest that the truncation and imprecision of the nomic lines are not as problematic as they might seem. The device may not have been used primarily to determine north, but to help navigators determine local noon, which in turn enabled them to calculate their latitude. To read latitude with such a device, a navigator would measure the sun's shadow precisely at noon, and the nomic lines would assist in determining the time of noon. Knowing their latitude would help navigators stay on course during the many east-west voyages between Greenland and Norway. If this theory is correct, the instrument would have two gnomons for two separate functions. A short broad one would have been used with the mnemonic lines to help determine noon. A higher secondary central gnomon would determine latitude. In support of this theory, the instrument has an engraved scaling in the northern part that may have aided the second reading. In this interpretation, the instrument could be thought of as a sophisticated type of sun shadow board. If you want to delve deep into optical physics, the article can be found in the description. For the time being, we do have to live with a little bit of speculation though, because in the end all we have is half of a presumed dial and some late references. Nonetheless, even without navigational tools, or especially without them, the achievement would have been grand, being able to find your way across the ocean simply by observing nature, from the skies and sea currents to bird species and rocks. So what do you think? Would you have dared embark on such a perilous journey? Write a comment or follow me for much more on the Viking Age. Till next time.